So for the first question, I'm given the graph and I have to make an equation for the polynomial. And first, to do that, you have to find all the x-intercepts, which is x equals -2, x equals -1, x equals 2, and x equals 4. And those are the zeros and the roots. And then what you have to do is you have to change the sign to make them factors. So x plus 2 equals 0, x plus 1 equals 0, x minus 2 equals 0, and x minus 4 equals 0. And those are the factors. So that's a factor, that's a factor, that's a factor, and that's a factor. And then you have to find the multiplicities for that. To find the multiplicities, you look at the graph, and if the x-intercept crosses through the x-axis, then the multiplicity is odd. So for this one, for x plus 2, that would be m equals 1. The next one crosses, so it would be m equals 1. It crosses through that point, so it's also m equals 1. And then when you get to 4, it bounces off and goes in the other direction, so it would be m equals 2. So using all of this information, you have to put it into an equation. So to start that off, you just put the y equals, and then just any variable. So I'm going to use a because we don't know the leading coefficient. And then we take these factors. So x plus 2, x times x plus 1 times x minus 2, and then x minus 4. And because that one has a multiplicity of 2, I'm going to square that one. Because all of these ones have multiplicities of 1, they all just stay multiplied by 1. There's no change in that. And then next we have to find a. And to do that, we have to use the y-intercept, which is -4. So then from that, we're just going to take the y-intercept and put it in as y. And then what we're going to do is we're going to plug in 0 for all of the x's so we can solve for a. So then 0 plus 2, 0 plus 1, 0 minus 2, 0 minus 4 squared. So then from that we just get -4, which equals a times 2 times 1 times -2, then times -4 squared. And we're just going to continue solving for that, which is going to equal -4, which equals a times 2 times 1 times -2, and then -4 squared is -16. And then we're just going to have -4 equal 64a, because the product of all of that is going to be 64. And then we divide 64 by both sides. And then we cancel those out. And a is going to equal 4 over 64. So now that we have the value of a, we can put it into an equation. So now we have y equals 4 over 64. And then we're going to put in the original factors. So then x plus 2, x plus 1, x minus 2, and then x minus 4 squared. And that's going to be our final equation. To confirm that the end behaviors on the graph and the equation are the same is by telling that if the equation starts with an odd degree, which it does, they all start with the degree of 1, it means that the end behavior is negative, which you can tell that it goes negative. So as it approaches negative infinity, f of x is going to be negative infinity. And when it ends with an even degree, which it does, it ends in 2 over here, the polynomial as it approaches positive infinity. Up here you can tell that it f of x also approaches positive infinity, and that's how you confirm that they're both the same. The correct factors and multiplicities up here because you use the x-intercepts from the graph, and that's how you flip the signs to verify and make them equal 0, and then if it crosses the x-axis again, then it means that the multiplicities are odd, which we did here, and if it bounces in the other direction of the x-axis, then it's going to be even, like we did with this one. So that's how we verify if the factors and multiplicities line up with the graph. And to know that your polynomial equation has the correct y-intercept is by using the y-intercept from the graph and then plugging it in for the y in your equation and then solving for a to get this final equation.